Okay, some questions ask you to find moles of one substance given moles of another substance. These are mole-mole questions. Now notice, mass is not involved here. Nothing about grams, nothing about mass. If moles and mass are both involved, that is a different kind of problem, and you're probably going to use the gram formula mass and the mole calculation equation. This is not that. This is just moles of one thing and moles of the other. And here's the notes that we need. Basically, use the coefficients in a balanced reaction to help you write a proportion. You're going to use the coefficients given because the coefficients are moles, but they're moles that can be scaled up or scaled down. So really the coefficients are mole ratios. Because if you wanted, you could double them or triple them or cut them in half. It's like a recipe, and you can adjust the recipe how you want. So you're going to take the coefficients that they ask you about, they're going to take the coefficients that they give you, you're going to put an x, and it's just going to be a simple proportion. So first of all, we're going to start with question 13 on version A, and it's also question 8 on version B. And it basically says, what are the coefficients? The coefficients in a balanced chemical equation represent, number 2, the mole ratios of the substances. There you go. Now let's look at a couple problems. Question 4 on version A is this reaction. It is also question 16 on version B. And I can tell this is what I need, first of all, because they give me a chemical reaction. And then second of all, because they mention moles, they ask for moles, and there's nothing about mass, there's nothing about grams at all. This question asks, what is the number of moles of H2O formed when 2 moles of NH3 react completely? So when they say, what is the number of moles of H2O? That's going to prompt me to put my x there above the coefficient of H2O. Maybe I want 6 moles, maybe not. Maybe more, maybe less. Probably not. Probably more or less. And let's see. The other thing it tells me is 2 moles of NH3. So I go over to the NH3, and instead of the 4 moles that the reaction shows, I'm going to say, oh, what if I had 2 moles? So only focus on the two guys they ask about. The oxygen and the nitrogen monoxide just don't matter. They're only focused on these 2 parts of the recipe. And then I just take this as a proportion. So 2 to 4 equals x to 6. You can cross multiply. It's pretty obvious that the answer is 3. 3 moles. Okay, now let's look at number 10. Number 10 on version A is the same as number 5 on version B, and it involves the synthesis of aluminum oxide. Again, they ask for moles, they give me moles. If it's all about moles, it's all about the coefficients. Okay. So when you hear them ask for something, decide where to put an x. When you hear them tell you a certain number of moles, decide where you're going to put that number. And it's going to all be about the coefficients. So how many moles of aluminum react completely to produce 3 moles of Al2O3? 3 moles of Al2O3. So my proportion is x over 4 equals 3 over 2. Again, you're going to cross multiply, and you'll notice, of course, that x is 6. Is that right? Yeah, 6 moles of the substance. And that's the answer. Okay, so hopefully you fixed this. Please feel free to write on your actual test, on that reaction there, put an x, put a 3, write all around it. And here is the question that you're going to tackle on your own. How many moles of hydrogen gas would be needed to produce 7 moles of ammonia?